So this is example 1 for section 5.2, where we are told to verify a trig identity. The identity in question here is secant squared theta minus 1 over secant squared theta is equal to sine squared theta. Whenever we're tasked with verifying a trig identity, you want to choose one side of that equation, the more complicated looking side, to manipulate so that you can make it look like the right side or the other side of the equation. So always identify the more complex side, and that's going to be the side that you're going to try to manipulate to make it turn into the less complex side. So in this particular case, we're going to go ahead and manipulate the left side because that's the side that's more complicated, which means we can make it kind of collapse into what we want it to be, which would have been sine squared theta. So first step is choose a side. And we're choosing the left-hand side this time. So what I'm going to do now is go ahead and write down my side and start trying to use all the various different fundamental trig identities to change things around and, swap things out, change the expression in any way. So rewrite and rearrange is what I'm going to call this step here. So we are going to rewrite and rearrange the left-hand side of this equation. So that's going to be secant squared theta minus 1 over secant squared theta. And we're automatically going to start off using any of the fundamental trig identities that could be beneficial for us here. Now, one of the first ones that I could think of using here is the trig identity that says 1 plus tangent squared theta is equal to secant squared theta. This is one of the Pythagorean identities again. So there were 3 Pythagorean identities, but we're using this one here because tangent and secant can be correlated using this particular trig identity. So secant squared theta minus 1, if you just subtracted 1 from both sides here, is going to be equal to tangent squared theta. So this is what we're going to be plugging in and substituting for our numerator. So this is equal to tangent squared theta. So let's go ahead and rewrite our expression with the substitution taken into consideration here. So that's going to be tangent squared theta for our new numerator divided by secant squared theta. Now, tangent and secant both contain a cosine in there somewhere, right? Tangent is sine over cosine, and secant is 1 over cosine. So there's a variety of different things and different ways we can kind of manipulate this new expression that we're dealing with here. So I'm going to go ahead and rewrite my tangent squared theta as the quotient of sine over cosine. So that's going to be sine squared theta over cosine squared theta, but this is still over the secant squared theta, which means I can write it as the product of what used to be the tangent and 1 over secant squared theta. But 1 over secant squared theta is technically just cosine theta because that's also one of the reciprocal identities. So this is just cosine squared theta. So I'm going to go ahead and substitute that in. So now we're going to get sine squared theta over cosine squared theta times cosine squared theta. And lo and behold, you have cosine squared theta in your numerator right here and in your denominator right there, so you can actually cross those out. They cancel. So now that they've canceled, all we're left with is sine squared theta. And we're done. Because we took our expression as it was given to us originally, and we manipulated it. We substituted different expressions. We were able to swap out the secant squared theta for the cosine squared theta, knowing that it's the reciprocal of one another, and basically kind of working our way through it step by step, we were able to turn the left-hand side of the equation, which we chose to start with, into the right-hand side of our original equation. So that is how you verify that identity. Now we can consider the problem completed. But this is the thing about using different algebraic techniques and algebraic approaches to verifying these trig identities, because this isn't the only way that you could have verified this particular trig identity. So let's look at it in an alternate method. So I'm going to look at it in a different way, and see if maybe there was a different approach. Maybe the way that I showed you just now isn't necessarily the way that you would have seen the procedure to follow. You might have a different approach to it. And this is basically just trying to show that you can have more than one possible approach that does still work. So the procedure that I'm talking about this time around is by, again, identifying which side of the equation we're going to start off with. So again, looking at the original equation we have here, we are going to go and deal with the left side because that is the complex side. That's the side that's a little bit more involved. So we're starting with secant squared theta minus 1 over secant squared theta. Now, instead of substituting the numerator for tangent squared theta, what if we did secant squared theta over secant squared theta minus 1 over secant squared theta? So I'm basically expanding my fraction and writing it as two separate fractions instead. Now, secant squared theta over here and secant squared theta in the denominator of that same fraction, they cancel each other out, leaving behind a 1. Then we've got minus 1 over secant squared theta. Now, again, 1 over secant squared theta is equal to cosine squared theta from the reciprocal properties and the reciprocal identities of the trig functions. So in this case, we're going to go ahead and say that that's equal to 1 minus cosine squared theta. And now we're tapping back into the Pythagorean identities that we could use, where cosine squared u plus sine squared u is equal to 1, which we can also refer to as sine squared u plus cosine squared u is equal to 1. So we could use this to say that 1 minus cosine squared theta from our procedure is equal to sine squared theta, which is, again, the right-hand side of the equation that we were looking for. So we took the left-hand side and we changed it into the right-hand side, and that's how we used a different method to verify, yet again, this trigonometric identity.